starting. I'm a plant pathologist with Alberta Agriculture and Irrigation, and they asked me to talk today about cereal leaf diseases. And so that's what I'm going to do. And thanks to Farming Smarter for the invitation to be here. I do enjoy talking about, looking at, and diagnosing crop disease issues, and so this is fun for me. So I hope it's going to be fun for you today. And one of the things that I thought might be fun would be to bring in some examples of disease symptoms on barley on this table, wheat on that table, and you guys are going to file through. You can go on both sides of the table. Let's start on this side and work this way. You guys can just come down and you're going to test yourself. I'm not going to test you. You just test yourself. And so look at the plants. You can touch them and have a look at them. Don't pull the leaves off though. Look at the symptoms and see if you can see the symptoms, figure out what might cause them and what you might do about it. Okay? So come on over. Everybody just walk through. We'll just go on both sides of the table. There's 1 through 5 on the barley table and there's 1 through 6 on the wheat table. And then when you're finished, I'm going to go through and show you what I know about these, because I know some things about these samples that you guys don't know. And I'll tell you what I know, and then we'll come to a conclusion about what we think is going on here. And then you can come back up and have a look after if you want to get a closer look at some of the things you maybe didn't recognize or didn't see the first time through. Some of them I think will be fairly obvious, and I've got a couple in here that I'm trying to trick you.
Of course you.
Never happens.
So some of these, well, first of all, I'll tell you, there's nothing here that's an exotic pest. These are all, either they came from fields very nearby here, or they were inoculated in a growth cabinet with a local isolate. So there's nothing new, there's nothing that we're spreading that's not already flying through the air today anyway. And so the ones that were inoculated in a growth cabinet, they pretty much just have the one disease on them. But the ones that came from the field, there might be more than one thing, but I think it's pretty obvious what it is we're looking at for just about all of them. There's only a couple of tricky ones. Yeah, Michelle? Got them all figured out?
I just thought but I read up on oats, but it's like it's like you need a place to take this out.
Is that the minus the most right?
What is it, right?
This actually is. This looks pretty good.
I looked at the oats yesterday. They look
Exactly.
and there's like some of the same variety. I seed treated this time. So I know seed treatment doesn't usually go some of those things.
That's my dad. He'll come back through once he tells us what they all are, and then that'll be really interesting. Once we know what to look for.
Yeah.
Any from your field?
Maybe.
Lots of groups. Yeah, we do. So some of the tests we do at Brooks, and the rest of it we send to the plant health lab at Edline. So we work real close with the Alberta Plant Health Lab. It's at CDC North in in Edmonton, and we're at CDC South in Brooks. So most of the samples we get come from Southern Alberta, and most of the samples they get come from Northern Alberta. And they can test pretty much everything there. We can't test everything in Brooks because we don't have the same staff and the same equipment. But there's some things that we can. Yeah, not necessarily everybody, but if you contact me, I can make it happen. So a cold
That's
call
what
to
I
the plant health lab,
But
you
they
might not get in. Yeah. So if there's a commercial test, we say, you know, we're not in competition with commercial enterprises. So you send, there's a commercial test you can pay to have it done. That's where you should go. But there are some things you can't get a commercial test done for. So we'll do those. But every ag fieldman in the county, they can send stuff in. So if you take it to your ag fieldman, they can do it.
We have some of
Or
that in our field.
like I can look at it and say, yeah, we need to test this.
Doesn't quite look like
Or I can
that.
say,
It's got
But
more.
this has got,
it's probably just
got spots on it.
Yeah, it's got more distinct
Same.
line down.
oh, did you?
A little bit more.
Is this
Yes. So you pre-ordered it. They just started shipping them last Monday. I'm glad to hear you got it. Because you're the first person that's confirmed that it's out now. With shipping. Was the shipping on it? Yeah.
Yeah, was the shipping more?
Yeah, because the book's $44.95.
No, what's the other one?
UPS.
It was on the doorstep. No one stole it. No one stole it. Well, no, we have a house in the house. I'll be honest, no, my dad's on those spots. If they couldn't smoke it, that's what they found.
Familiar, hopefully you saw something new. Let's talk about what we saw. Okay, so I'm going to do this a little different than I did with the first group. We're going to go through these kind of in groups. So the first group we're going to go through are fungal leaf spot diseases on wheat and barley that are very common. Okay, so number 2 on the barley table is spot form net blotch and its closely related cousin net form net blotch. So they're very closely related organisms and they have a little different symptom. One is a spot and one has kind of a long lesion that has a ladder-like network. That's why it's called net blotch. And then a different organism that causes something called spot blotch. And then in the wheat, we have tan spot. And I don't have examples of scald in barley or Staganospora in wheat or speckled leaf blotch in wheat. So those are some other commonly occurring fungal pathogens. So we see these in wheat and barley every year. And they're usually the most prevalent diseases. So scald in barley and or at least the net blotches are some of the usually the most prevalent. And then in wheat, it's tan spot. It's usually the most prevalent. Then we also will see some Staganospora and a little bit of speckled leaf blotch. So these pathogens are residue borne. That means that when you grow a host crop and then you harvest it, the pathogen is still in the residue that's left behind, and that's the inoculum or the disease potential for the next season that there's a crop. So if you grow barley and then you grow barley again on the barley and you grow barley again on the barley, you're increasing the amount of inoculum or disease potential, and you're going to start to see more and more of these. So crop rotation to allow that crop residue to break down. So a 2 or 3 year break in between host crops will reduce the level of disease risk or potential by a significant amount. There is also some genetic resistance, but fungicides are quite effective. If you can protect the upper canopy leaves with a fungicide before they're infected, you can manage these diseases quite successfully with crop rotation and fungicide applications. Okay, so they didn't want me to spend all my time talking about fungal leaf spots because I think you guys have heard about these before, you've seen them before, you've managed them before. So let's talk about some of the other ones that I am trying to trick you on. Yes, question?
So you mentioned fungicide application for control. How much yield impact will the control actually have in an average year?
So there's 2 things that you're going to want to think carefully about, and one is the yield potential of the crop, and the other is the disease potential of the crop. And in most years, when you have a high yield potential, you also have good conditions for disease. And that's when your fungicide is going to really protect you against yield lost to infection. So if you have a high yield potential and significant disease potential, that's when the fungicide is going to be able to really protect things. Now, if it's a droughty year and there's no yield, you're not going to spray a fungicide. That's obvious. But if you have a good crop and not a lot of disease risk, then you're not going to see a lot of response for the fungicide. Now, in a case where you have really high disease pressure, that can sometimes overwhelm the ability of the fungicide to control the disease. And so you can sometimes, in those really high pressure situations, get some suppression, but you don't get really good control in the upper canopy in those conditions. So it really kind of depends. Did I answer the question at all?
So in a normal year, how much yield advantage would I experience with a fungicide?
It depends on your rotation. It depends on the environment, and it depends on all those things. So you got to scout and look. And when you start to see these kinds of symptoms, you don't want these getting up onto your flag or penultimate leaf in barley, and you don't want them on your flag or head in wheat. And so you got to protect those with a fungicide. And so when there's yield potential and disease potential, you'll get good control and you'll get a significant yield response to the fungicide application if you get it on in time. Yeah, but it really depends. So it's not something you can do the same every year. You got to monitor and evaluate the risk and all that kind of stuff. Yeah, that's a great question. Okay, so let's jump into some of these other ones. I've got an example of, did anybody guess that number 2 on the wheat table was powdery mildew? You don't have to answer because I'm not quizzing you. You can quiz yourself. Powdery mildew, I'll talk to you about why I'm saying that. And on this last one, did anybody guess stripe rust? Again, it's a rhetorical question. You don't have to answer out loud. Okay, so why am I saying powdery mildew here? When you look down on these lower leaves, some of them will be yellow, and then they'll have little green islands left over. I think I pulled the other one off that was the best example, but you see where it's yellow there? And there's little green spots? That's a very typical powdery mildew symptom. It's called a green island. So the leaf turns yellow, but where the fungus is in the leaf, it stays green. So those green islands are a characteristic symptom of powdery mildew. So that's one of the things that you can see in the lower canopy. The second thing that you can see in the upper canopy is the actual powdery mildew. Now these have been blowing in the wind all day and drying out a little bit, but some of these leaves have powdery white, it's hard to see on these, this isn't the best example, but you'll see a powdery white spot. And those will get bigger and bigger, and so probably a lot of you, if you grow winter wheat, you've probably seen powdery mildew. It's also relatively common in Durham the last few years. So powdery mildew we can also manage with crop rotation, resistance, and fungicides. Okay, stripe rust. This is not a residue-borne disease. This is a disease that doesn't overwinter here, usually. It's only happened once or twice in the last 25 years. It blows in, spores travel through the air from the Pacific Northwest. That's where our spores come from here in southern Alberta. And on the years that they come early enough, they can cause significant damage, especially in susceptible varieties. So we manage stripe rust with resistant cultivars, and fungicides are also effective. But you have to get the fungicides on before the flag leaves or the upper canopy gets colonized too heavily. Stripe rust is a disease, and powdery mildew as well, that when the conditions are conducive, it's very explosive and it moves really quickly through the crop. So you have to be scouting for it and aware of it and be ahead of it. Okay, so now there's a couple last things I want to talk about here, and that is the non-fungal diseases. Okay, so the first trick that I played on you is that this isn't barley, it's wheat. But so this wheat here is the same as this wheat here. It's just that they were seeded at different, they were inoculated at different crop stages. And they were inoculated with Xanthomonas translucens, the bacterial leaf streak pathogen. Now, the other trick here is that Xanthomonas translucens, pathovar translucens, is a good barley pathogen. It's not a very good wheat pathogen. And that's what we inoculated it with. So these symptoms are atypical. But if you look closely, you can see some of the streaking, but most of the symptoms you see here are just the leaves that got colonized or dying. So, but if you look close, you can see the streaks. And one of these leaves had a really nice translucent pain symptom. That's why it's called translucens. It's because the leaves, where the lesions are, can become kind of see-through or translucent. Okay, so that's bacterial leaf streak. Now, this is a more challenging disease to manage because we don't have resistant cultivars and we don't have bactericides that we can deploy like we do fungicides. So it's quite challenging to manage, and we know that it's seed transmitted, but what we don't know very well is if you have a seed lot that has risk, what does that mean at the end of the season? Are you going to have yield loss? We don't know the answer to that. So sometimes you can have the bacterium on the seed and you don't get any yield loss. Other times you can have bacteria on the seed and you do. And that all has to do with the environment and how that plays out. And we aren't very good at predicting what's going to happen. So it's challenging, and we don't really have good techniques or tools to manage it. So there are researchers working on breeding tolerance or resistance to the pathogen, but that takes time. So we're waiting on that. The one thing I will say is, if we can't do anything about it, why do we care? Well, if you have a bacterial leaf streak problem, a fungicide isn't going to help. So it's an unneeded input cost for you because it's not going to control the problem. And it's also a selection event for whatever fungi are in the field. So if you have a bacterial leaf streak problem, it's good to diagnose that and just know that you don't need to spray a fungicide on it. Now, if you have bacterial leaf streak and fungal leaf spot, you can still control the fungal leaf spot with the fungicide, but not the bacteria. Okay, viruses. I'm jumping pretty quick because I think we're going to run out of time here in a couple minutes. So this might be barley yellow dwarf. So it's suspicious for it. I saw these plants yesterday and I collected them. Haven't confirmed, so it might not be. But if I saw this plant in my field, you can see the symptoms are at the tips and the margins of the leaves. It's not really very common in the lower canopy. It's in the upper canopy. And there's purpling or red, kind of red wine-colored discoloration. That could be barley yellow dwarf. So I'm going to test that and we'll see. So when you see those kinds of symptoms in barley or oat, it's good to confirm. Now this is an aphid transmitted virus. We're going to talk about management of viruses in a bit. But the other one I want to show you is the wheat streak mosaic in Durham. So this is a great example. Do you see how none of the lower leaves have symptoms? It's essentially just the flag leaf for the most part. So the wheat curl mite is the vector, and it doesn't have wings, but it's passively dispersed in the wind, and it's flying through the air, and it gets caught by the flag leaves that are sticking up like this, up high in the canopy. So that's why we see the symptoms there first. And we don't really see any symptoms down low lots of times. Okay, so that's 2 viral diseases. Sometimes I hear people say, I don't have any virucides, I don't have any miticides, so there's nothing I can do. Well, at this stage of the crop, you're right. There's nothing you can do. But the only reason we have wheat streak mosaic is because we green bridged it from one season to the next. The virus and the vector cannot survive unless we give it a green bridge. What do I mean by that? It's in the spring crop, and then the fall seeded crop comes up and it bridges to the fall seeded crop, and then it can overwinter in that dormant host. The host goes to sleep, the virus and the vector survive, the host wakes up in the spring, and now you got wheat streak mosaic in May. And you might have to plow that down or use it as green feed because you might not get a grain crop out of it. So the reason we have wheat streak mosaic is because we green bridge it. We have complete ability to break the cycle. So yes, there is something you can do about it, and that's break that cycle. That means you don't want your fall seeded crops coming up until your spring seeded crops are harvested and gone for a week or two. And then you've broken that cycle. They can't survive more than a couple of weeks, they're dead. Your fall crop comes up clean, and then you don't green bridge it.
Why would anybody want to cover crop?
So there's a lot of good reasons to cover crop, but you have to not green bridge viruses. Yeah.
What about distance?
Yeah, that somebody asked that question last session too. And the answer to that is it's hard to say because it moves passively through the air. The vector is what moves it, and the vector moves passively through the air on wind currents. So right now, if there's wheat curl mite in that crop, it's going that way. And it can go across the road for sure. Okay, maybe even further. Later today, it might be going that way. And how far it goes depends on the turbulence and the wind and all these kinds of things. So it's difficult to predict. What I will say is that we've had at least 4 or 5 green bridge events in southern Alberta, but wheat streak mosaic is very widespread in southern Alberta right now. It's present in many, many, many crops because the wheat curl mite moved from field to field. So how far away is far enough away? That's tough. As far as you can get. It's not a great answer, but there isn't a great answer. Yeah, it's a good question though. The key is that you don't have, when you're harvesting your spring crop and the crop is maturing, that's when the wheat curl mites are letting go. If the crop isn't green, they're not going to survive. So as soon as the crop starts to turn, they're letting go and going up into the wind and trying to find a new field that's green. So if there's no winter wheat or fall rye or whatever, fall seeded crop available to get into, then we're good. How far? Miles?
Are roadside grasses a host?
Great question. Are roadside grasses a host? The perennial grasses are a very weak host. So the vector can survive in the some of the perennial grassy weeds that exist in the field margins and ditches, but they don't survive very well, and I don't know that the vector survives. So those can kind of be a reservoir, but if the vector doesn't survive, then it doesn't spread. So yes, they are potentially a host, but we've never seen green bridge events from ditch grass or perennial weeds or grasses. It's always, so the most susceptible hosts are wheat, and winter wheat is a great host, and that's usually the green bridge host. Yes, Joshua.
So then in general terms, like I wouldn't, like obviously you don't want to go cereal to cereal if you can, but there's a lot of that. But if you go from, say, a barley spring and then you see winter wheat later, like there's no, because from what I'm understanding, there's a lower chance of silage fall back.
Yes. So the virus and the vector will survive for a week, say. So if something's coming up nearby within that period of time, it's going to get in and start causing disease. Now, if we're talking about barley yellow dwarf going from, say, barley or winter wheat to an oat crop that's been double cropped, that's a very different situation. And with barley yellow dwarf, it's not a green bridge issue, it's an aphid migration issue. And so for controlling barley yellow dwarf, you try to seed your crops to avoid the big aphid bloom in August or September. Whenever the aphids arrive, they arrive with the virus, and that's usually when we see it. So if your spring crop is seeded early enough, you get your crop finished before that's an issue. And if you seed your fall seeded crop later, then you can avoid a lot of that issue. But when you've got them back to back like that, it's just, if the virus is there and the aphid's there, you're just going to have problems. Yeah. Okay, last one. Boy, does this ever look like tan spot or some other fungal leaf blotch. This is physiological leaf spot. So I'm going to tell you why I'm saying that. So these plants were collected 3 weeks ago and put in these pots, and so they're not doing too well. You can see there's some of the leaves, some of the older leaves are dying off. But when this came to us, it was completely green, and there was almost none of these symptoms in the lower canopy. They were all up high, and they were a lot of them at the tip. That's very characteristic of physiological leaf spot. But the thing that really tipped us off was how quickly the spots just appeared, almost like overnight spots, and then they didn't get bigger, and they weren't more severe in the lower canopy. There was almost no spotting in the lower canopy. It was all up high, and that's characteristic of physiological leaf spot. So we did test these, and we didn't find any evidence of infection. So with physiological leaf spot, you test for the pathogens you can test for, and if it's all negative, then you say, well, maybe it's physiological leaf spot. There's no marker to test for physiological leaf spot. So we rule everything else out, and when the symptoms align like this with high in the canopy, kind of appearing overnight, and then the lesions don't spread or coalesce like the fungal leaf spots do. Those fungal lesions are going to get bigger, they're going to coalesce, they're going to kill the leaves, and that's not what's happening here. The spots appeared and then they just stayed that way for 3 weeks. So, physiological leaf spot. And there was a lot of this in Montana this year. We got an alert for it, so we were kind of wondering if it was going to show up in winter wheat, and it's very common in winter wheat. Some varieties are more predisposed to get it, and a chloride deficiency can also increase the severity. So sometimes, like you'll say, well, if it's physiological leaf spot, how come it's not through the whole field? Well, it's only present in areas where it doesn't have enough chloride, or it's only present in areas where the environment kind of brought about the symptoms. So how does the environment bring about the symptoms? What they've shown is, so some varieties are more predisposed to it than others, but what triggers it is you get cloudy weather, and then all of a sudden, kind of instantly, the clouds go away and it's very bright. And so that shock, that sunlight shock going from cloudy to very sunny in a short period of time, it just induces this physiological shock symptom that shows up and then just stays that way. And it's usually in the upper canopy where it's getting most of that sun shock from. Okay, did I miss anything? Last thing I want to talk about is resources. So what are some things that can help me monitor, assess, diagnose, and manage fungal leaf spots? So there's a new edition of the book, Diseases of Field Crops in Canada, that just is kind of brand new. It just started shipping last week. If you're interested in getting a copy, it's $45. There are cards here, and you contact the person on the card. Her name's Bev, either by email or phone, and you can get a copy of that. The other thing I want to mention is the Prairie Crop Disease Monitoring Network. So if you'd like to go to the website, each of these papers that I put here have a QR code on them, and you can just scan that QR code and it'll take you to the website. And there's all kinds of stuff on there. I want to talk about two things. One is these are called disease scouting cards, and I have them for 4 of the diseases here, and I also have them for bacterial leaf streak. This one has been printed and laminated, and you're welcome to take one of those if you want. The other thing I want to mention is the stripe rust risk. There's a weekly stripe rust risk that's posted on the website. Kelly Turkington does this. And what they do is they look at reverse wind trajectories from the areas where stripe rust overwinters. So for us, that's Pacific Northwest. So it looks for the crop development and the stripe rust development in the Pacific Northwest. And then it looks at when air parcels move over that and come to us. And then it produces this speedometer that tells you what the relative risk of stripe rust showing up in southern Alberta is. And so the last one that was put out last week gave a low risk, but there was an alert that just came out yesterday that said stripe rust has been confirmed in Montana, and we can kind of expect to see it anytime in Alberta. So Prairie Crop Disease Monitoring Network is another resource that has lots of information that may be of use for evaluating, assessing, diagnosing, and learning about management of some of these diseases. Okay, so my alarm's going off telling me that we only got a minute or 2 left. Let's do some questions. Yes?
Is it a danger for barley or durum or most of spring wheat?
Yeah, so hosts of stripe rust. So the stripe rust that you see at the end of the table there, that's a wheat pathogen. There's a different cousin called Forma specialis that, so the pathogen is called Puccinia striiformis, and this is a Forma specialis on wheat, and then there's a different Forma specialis that causes disease on barley. Now they can overlap a little bit, but very weak. So the barley pathogen doesn't cause a lot of disease on wheat and vice versa. So you can see stripe rust on wheat. It's a different pathogen, different Forma specialis, and then on barley than it is on wheat. And they don't really cross over very well. Normally when we see stripe rust, we mostly see it on wheat crops. And it can survive on winter wheat when we have mild winters or a lot of snow cover.
What about Durham?
Durham is a host for sure. Yep. Yep.
Do you do any spore trapping? Is there any spore trapping for this stuff?
So for the cereal diseases, no, but there is a spore trap for late blight in potato, and there are some research trials that are using spore traps to figure things out, but there's no spore trapping network that's going to put out alerts. It'd be nice to have. Like stripe rust is one of those diseases that travels hundreds of miles through the air, and you can trap it in the air and it's a recognizable spore. You could test it by PCR or just looking at it. So stripe rust would be one of those that you could have a spore trapping network to find it early before the symptoms show up in the crop. Yeah, it's a great question.
Is it also available for canola, for sclerotinia?
Yeah, so for sclerotinia, spore trapping, I suspect that early alerts for sclerotinia and canola are going to be biosensors, because those sclerotinia spores don't fly long distances through the air. So stripe rust and late blight on potato, those propagules fly kilometers, even tens or hundreds of kilometers through the air. They're adapted to survive UV exposure and avoid desiccation. Most of these other spores flying through the air, after a day or two, they're dead. And that's the case for sclerotinia. They aren't going to survive in the air for a long, long time. And they aren't going to disperse more than meters. So you can do early warning or alerts for sclerotinia, but it's going to have to be more localized. So for stripe rust and sclerotinia, you could have 10 traps in southern Alberta, and if those stripe rust or late blight is there, you'll find it in the spore trap. For sclerotinia, you'd have to have a trap in every field that you wanted to monitor. And that's why I think the biosensors are going to probably be the way for early warning for sclerotinia. Did you have a question? Somebody back here? No?
At one time, didn't they monitor stripe rust in Creston?
Yes.
That would give an indication of when it might come here.
Absolutely, yeah. There were some sentinel plots in Creston, and when the stripe rust showed up there, then they knew they were probably days away from seeing it in Fort McLeod and Lethbridge, and yeah. Yes.
Are there
Yes, Rosie.
resources to help people easily weed out the disease symptoms so far that you're aware?
No. So that it can be challenging to, you see symptoms and you wonder what it is that's causing them. It'd be nice to have a key to help you work through that. There's some things in development, but I'm not aware of anything that, some of these disease cards are probably right now kind of the best quick and dirty assessment. Now for some of these things, like I'm going to test this for barley yellow dwarf, but it could be negative. So there are some of these diseases that the symptoms just aren't good enough to tell you what it is. You have to do a lab test to confirm it. Things like aster yellows, wheat streak mosaic, barley yellow dwarf, physiological leaf spot. These are things we have to test to sort out. And so if you see something unusual and you need some diagnostic support, you can call me and we can see if we can figure it out. Some of the easier ones, like the fungal leaf spots, there are keys and cards and things to help you understand what those are. But there's some that you just need diagnostic support. Yeah. Okay, thanks guys. Enjoy the rest of your day.